Welcome back to this next section of functions. I refer you to 4.7.3 of your notes. How do we find the range of a composite function? Say for example, we want to find the range of a composite function fg. There are two methods. The first method is just simply find the expression fg, which we have learned in the previous section, expression fg, and then sketch that composite function. It's actually something that you know how to do in the previous section. Just find the expression and then consider that the domain of fg is actually the domain of g, sketch fg, and we're done. It's rather straightforward. However, there are some questions that we have to use method B, which is essentially to use the range of g as a new domain of f and to find the new range from the graph of f. Now this is a bit abstract. Maybe let me illustrate. Suppose you want to find fg, essentially it is g first. And you have a set of numbers, say 1, 2, 3, 4, doesn't matter, right? A set of 1, 2, 3, 4, you will get this is what a set of numbers that is actually the range of g, correct? This is the range of g here. This is actually the range of g. Now, to find the ultimate range here, which is here, you want to find out what happens when this set of values, which is essentially range of g, is mapped under f. This is the set of values here. This is actually the range of fg. So you will use this range of g as a new domain for the for the function f, then find the new range. I know it can be a little bit abstract. Let me illustrate using an example. Let's look at example 14. I want to specifically only look at part 2 because part 1 you can read on your own. I want to use two methods to solve example 14. Method A to solve fg is very simple, right? It's just to find the range of fg. Now to recap, fg x, very quickly, you have learned in the previous section, which is not a problem, is this, x plus 3. You do it yourself. I don't think it's difficult. You just substitute in, you will get x plus 3. Now, how do you find the range using method A? You just sketch x plus 3. But you do not just sketch this like that. Why? Because take note that domain of fg is actually domain of g, right? Which is here, which is from 0 to infinity. So you sketch it with this consideration of the domain like that, and this is 0, 3. Right? So with this domain from 0 to infinity, then the range of fg, which is the set of values y can take here in your graph, will therefore be the range of fg equals to 3 to infinity. Now you must exclude 3. You must exclude 3 because here is a hollow circle, because you are actually not including, I beg your pardon, I think I wasn't very clear here. This is a round, right? Like that. So method A is easy for this question. In fact, most of the time is easier for most students. But let me illustrate method B. Same question, let me use method B. Now, let me recap again that same diagram that I drew just now. This is G, like that. This is F. Right? Actually, this is your FG. Right? This is your FG. Now, don't care about this one first. Then let us think, actually under F, I'm sorry, I beg your pardon, under G, what is the actual range? What is the range? It's not difficult to find range of G. And you actually should have found it in part 1. Alright? range of G, if you do a quick sketch, range of G is simply 2 to infinity. Right? Because the graph of G, I do a quick recap, is like that. This is G. Like that. You sketch, you will know. Don't believe, you just pause the video, use your GC, you will be able to do this. Range of G is from 2 to infinity. Now, what we are saying is this. Ultimately, you got 2.001, 3, 4, 100, blah, 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 blah. These values is going to be met under F. And you ask yourself, what is then this ultimate range that you have? How do you then find it? Of course, we have to make use of the graph of F now. Let's look at F. Let's sketch F. I'm going to sketch F in dotted line first, then I will explain why I do that, right? Actually, F is like that. If you sketch the quadratic graph, it's like that. Right? But actually, F can only take on greater or equals to 0. So actually, it's only like that. I don't even bother about this one. Right? I don't bother. It's only like that. But it is further restricted because you look at the values here, you are substituting 2.001, 3, 4, 100, all the way to infinity to have images under F. So you are not going to substitute this 0 in, you're not going to substitute 1 in, you're only going to start from 2 here. You're going to start from 2 here. So from 2, but it's not 2 because take note, it is strictly greater than 2. So 2 to infinity. That means like that. The drawing is not great, but you get what I'm trying to say. So when this is 2, you substitute in here, you get 3. Therefore, final answer, you look at, this is actually the graph. Take note, this is the graph of F, not FG. Final answer, range of FG is 3 to infinity. Of course, it should give you the same value as method A earlier, and this is method B. Clear? Very good. So now that we know method A and method B like that, let me use another example to further illustrate the power of method B. All right. Example 15, I'm only going to talk about the range of FH. Now this is maybe you want to star this one. It's a classic example of how method A does not work. It wouldn't work. I show you first and then you tell me why it doesn't work. Let's see. I show you method B first. You want to find the range of FH. Again, FH means this H, then F, right? And what is the function H? Is a rather complicated looking function, lambda sine x. Now, first I need to find the range of H. You're going to substitute from anything from 0 to pi. Right? You're going to substitute from anything from 0 to pi. How does the sine graph look like from 0 to pi? Right? We are going to look at here. It looks actually like this. Oops, sorry. Like this. Right? Because sine graph. But now you multiply by lambda. You should know this from your physics, that this is the amplitude. So this point is actually pi over 2 lambda. This is what we call the amplitude. This is your sine graph. Right? This is actually the graph of H. Now therefore, I can now say that the range of H is actually from 0 to lambda. 0 to lambda. Now, that means here you actually have 0, 0.1, 0.2, all the way to the value lambda. You're going to substitute 0.1, 0.2, 0, 0.1, 0.2 in f. Here, then we have to look at the graph of f. That means you're going to substitute these values into f. As the restricted domain, why do I say restricted domain? Because f's domain is actually all real numbers. But now we are only going to restrict it from 0 to lambda. Right? 0, 0.1, 0.2, all the way to lambda. So, can we sketch this quadratic graph? Of course we can. Actually, the quadratic graph actually look like this. I'm going to sketch in dotted line like that. You can use GC to sketch, not a problem. Actually, it's like that. Okay? And if you want to find out the minimum point, you can easily use technology, use GC to find out where the minimum point is somewhere there. But you are not going to substitute negative values in. Because let's look here again. Let me illustrate here again. You're going to substitute 0, 0.1, 0.2, all the way to lambda in f. So you start from 0. So actually it is this one only. Only this part of the graph. So you're going to substitute 0 in. To sub 0 in, your y value is 1. So actually this value is a 0, 1. But you will end off somewhere. Lambda is a positive constant. So you cannot, it doesn't go forever and ever. Actually, it stops here. Correct? You're going to substitute all the way. The maximum value of here is lambda. When you sub lambda in, it's just a lambda square plus 4 lambda plus 1. So final answer, range of FH is just 1 lambda square plus 4 lambda plus 1. You may want to replay the video again if you don't understand this part. Thank you.